Good morning. You are in room A. This is a new geological map information service from the Kentucky Geological Survey with Mr. Douglas Curl. He is with the Kentucky Geological Survey. He has worked with them for 22 years, and he is currently the head of the KGS Geoscience Information Management section. While at KGS, he has acquired a range of experience working with the geoscience GIS related data, including developing web mapping services, digitizing data management, GIS analysis, and GIS base field data collection. Doug has an MS degree in geology from the University of Tennessee and a BS in geology from Guilford College in Greensboro, North Carolina. You can go ahead, sir.
All right, thank you. Can everybody see the slide? Hopefully, and not the notes page. I'll just change something. All right. The purpose of my talk here is to really introduce a new version of our Geologic map service, and but also I thought I'd go back and provide an overview of why and how we've developed it over the past 15 years. I was looking back recently. I was like, oh, that's okay. It's been up for a long time in many different versions, and so I thought I'd just give a little overview of that and maybe give some context for what this map service does and what the purpose is, and then I'll try to attempt a demo of the new application. So if you've used the older version, hopefully this will provide some new insight to the data behind it and about the new changes, of course. We try to keep many of the new features and tools as the previous version, but this design is very different if you're used to the old version. If you never used it, then this will provide hopefully a good introduction to the service and what it provides, and then also maybe give some insight to the technology behind it. And you know, I'm always interested in learning more about what we can do, and if you're interested in what I've done here, then you know, I'm happy to share. So and then I think, of course, just to keep with the theme, I think this application helps realize both the below, of course, because it's geology, and then also some of the above as part of this conference theme, and maybe beyond, I don't know. I can't decide that, but so if we look at KGS data, we have a lot of database records and a lot of GIS data that we store at KGS. We have over, the last count, 16 million KGS records. A lot of this is oil and gas related. We have wells from the Division of Oil and Gas. We're the official repository for their documents, and so we keep also their oil and gas well data. Of course, coal data, groundwater. We're the Kentucky Groundwater Data Repository, so we keep groundwater wells and springs, that sort of thing. Of course, minerals data, because we're the Geologic Survey. We do have minerals beyond just coal. We have a lot of limestone, fluorite, barite, et cetera, which are actually becoming more relevant lately. And then geotechnical data, we work with the transportation with their geotechnical data. And then we have, of course, publications, and then geologic mapping is sort of a core thing that we do at the survey. And I'll talk a lot more about this data. And really our crown jewel data set for GIS data is our digitally vectorized geologic quads, which I'll talk about more. We currently now have a program to map surficial geologic map data. And if you saw Steve Martin's talk yesterday, he talked a lot about this. I won't hit on surficial map data much, but if you missed his talk, you'd probably catch it when it's recorded. It was very good. Just promoting our survey, I guess. And then we have locations of other database records. If it has a location, you know, we can plot it basically. And then from the Kentucky From Above program, we have a copy of the statewide LIDAR point cloud, including the hillshade that was derived from them and that sort of thing. So a lot of data. Something I won't hit on at all is also our documents. We have a lot of oil and gas documents because we're a repository. Of course, our publications, and then water wells and spring documents as a part of the groundwater repository. So all this to say, you know, we need a way to provide this to the public, and you know, traditionally people would come in, look at oil and gas documents, particularly other maps and that sort of thing. But since 1996, we've had a website. It's one of the most popular at UK. I will say a lot of that popularity is from our education pages, which we have some really good education pages. But in 2001, we started developing dynamic web services and internet map services to give access to our database records and GIS data, access to those scanned documents. And we made a decision early on that all of this should be provided at no cost to users. For one thing, it's easier to do that, but also we just felt for public service, it's important to do that. A lot of this data has already been paid for by your tax dollars. So that was a decision we made. Also, I'll hit on this a little bit, but also to make it as technologically easy as possible without plugins and that sort of thing on the web browsers. So in late 2004, we debuted our Geologic Map Information Service, which I'll talk more about here in a sec, but that's just a listing below there of all the services and things that we provide. But I'm here to talk about the Geologic Map Service and what it is and what's in it. And really the story of this map service goes back to actually 1960. We wouldn't have the data to put in it without the Joint Geologic Mapping Program with KGS and the USGS to produce detailed 1 to 24,000 geologic maps for the entire state. We were the first state to do this. We remain one of the largest states to have that detailed mapping. There's some smaller states that do. And it was a very successful program that produced 707 individual geologic quads by 1978. So in a very, in geologic mapping time, not just geologic time, but geologic mapping time, a very short period to get that done. So in 1996, KGS started a program, again funded a lot with USGS funds to convert those 707 paper maps into GIS data sets. And so we took the maps, we scanned them, registered, rectified them. If you're in GIS, you're familiar with that process. And then we digitized the features with an army of KGS staff and students and employees using ArcInfo and AMLs, and I think Jack hit on that yesterday actually, using that technology. So we digitized all the features from the maps that we could, geologic units, geologic contacts, faults, and other features. And at the same time, we made a decision to scan in the stratigraphic descriptions from the maps. If you're familiar with a geologic map, on the collars of the maps, they have descriptions, very rich information about what the geologic units are on a map. It's not just colors, but there's a description that the geologist used to describe that, wrote to describe that unit. And so we scanned those columns in, and then we used OCR to put them into our database. I don't know what that little weird arrow is, but anyway, we put them in our database, and the importance of doing that was we could arrange the units by stratigraphic position, and so you could query the database and bring them back in stratigraphic order, which to geologists is really important to be able to put them into order from oldest to youngest, say, or to order them by rock type. But particularly age is really important when you're looking at geologic units and knowing what's on top of another unit, basically. So we stored all those descriptions, the metadata about them in our database. And that comes up here in a bit on why that was important. So the program finished in 2006. And then we compiled all of those 707 geologic quads into a seamless detailed geologic map data set for the entire state. So again, we have detailed polygons and faults, detailed contacts, structure contours, and then other features including coal beds, non-coal beds, things like limestone beds and clay beds and that sort of thing. And at the first glance, it just makes a beautiful map of the state. It's very detailed, and you can really just, by just looking at the state, see a lot of things pop out. All right, so in 2004, actually even before we finished the mapping program, we started developing a map service. Really the only other way that we got this data out to users was make paper maps from the GIS data, which is fine. We also provided a way to, you could order a CD of the data with shapefiles for each 707 Geologic quad, DVGQ if you wanted to do that. Now you can actually still get that data by going to our list of publications and looking up a GQ and getting the shapefile data. So that's still available, but I don't think anybody wants a CD of the data anymore. But we wanted, internet mapping was starting to take off around this time, and we really wanted to provide this over the internet to users at their fingertips, basically. So we started developing a map service using ArcGIS and the ActiveX connector. So it was a customized map service. And we also decided to put a lot of our other data on there. So oil and gas wells, water wells, because a lot of our users don't have they still don't have GIS capability. And this is their one stop that they come to for overlaying geologic data onto a map. And so providing the geologic data with the things like oil and gas wells or water wells with the context of the geologic map is really important to people. And they don't have to use the GIS. So the ActiveX connector, it worked well. The nice thing is you didn't have to have a plugin or that sort of thing. The problem was if you dealt with ArcGIS, it was unstable is a good word. It was unstable. It was very slow loading, but it worked, and we stood that service up until 2010 and made a lot of little improvements along the way, and it actually got more stable as we went. But in 2010, ESRI finally stopped supporting ArcGIS, and we finally decided to move to the ArcGIS server world, which was a really great thing. It was nice to have an excuse to redevelop the service, and so we redeveloped it using the ArcGIS JavaScript API, and then put our data into ArcGIS server and redevelop the application. And as a result, you get that, the Slippy Map application, which around 2010 was a, kind of revolutionary, thanks to Google Maps and that sort of thing. And it was awesome. You just had a much faster map experience. Again, it was a customized map application, and we also put this other data in there. The oil and gas wells, the water wells, because of the same concept that people want to overlay those things. So kind of breaking all those rules about making map services with tons of layers, we actually get really good feedback about doing that. And then in 2013, this map application wasn't responsive to mobile devices, so we developed a mobile version in 2013. It's a separate map application, again, developed with the JavaScript API. It's not an app. It's just a web service, a web application, but it's separate. It contains a lot of the same data, but it's just a lot simpler to use, and you can use it on a phone. But the problem is you have to, develop one and then make the changes to the other. So it's like two applications to keep track of. So just looking at our usage over time, kind of plotting this out. I said before, the big user of our data at KGS is oil and gas users. And so I thought, I'll just plot this with, oil prices. So it's crude oil prices from the US over time since 2004 on the left to 2020 on the right. And we average about 62,000 users a year, but there are fluctuations that I think are real with oil prices, and you know, we get the feedback from the oil and gas community that that's the case. That you know they use this map service to look at their oil and gas data a lot. The oil and gas data usage is magnitudes higher than the usage from our other services, and then they can link to the map service, and this is what you get. So I think that fluctuation is actually kind of real, which is kind of neat. And then I also plotted the mobile geologic map service. It gets a little washed out there, but that usage has increased about 30% for that mobile map. And so it kind of, you know, by 2020 now, there's newer web technology and that sort of thing. And so we decided to really just completely redevelop this map service. And it debuted in March 2020. And I'll get into some of the technology, but really we wanted to take advantage of cached layers to make things faster. We wanted to look at the detailed geology at all scales. We wanted to give people more fine-grained control over the geologic map that they can display. And some other, we wanted to integrate some other tools, but really important was to make it responsive, to make it useful on a mobile and tablet, so we didn't have to maintain two applications. You didn't have to remember, or we'd have to redirect people to a new application. So the new Geologic Map service uses, again, we're still in ArcGIS server world, which is great. So we're not using ArcGIS Online. We're still standing up our server 10.61 if you're curious. And now we have a lot of cache services. So we finally cached our geologic layers. We have 11 of those, 57 total services in the application, which may make somebody at ESRI head explode. I don't know, but you know, again, it's just important that we provide an easy to use all one-stop place for geologic data. So most of our data is from KGS, but we also take advantage of KY raster, the Kentucky from above imagery, and then also the LiDAR hillshade. The most beautiful, and then of course the topographic maps make beautiful base maps for this, and then and also from the Kentucky Geography Network, KYGS server.ky.gov. And then we're using the newer version of the JavaScript API. The old version was like version 3, and that's still around, but they've redeveloped the whole API, and so now we're using 4.13. But 4.x basically. And just coincidentally, we use the calcite maps layout. It has nothing to do with geology, but it's kind of a cool geologic name, but it makes a nice streamlined look. And actually, we still use ASP pages on the very back end to make SQL queries to our database. And we return that data in JSON or HTML and then display it on the map service. So I'll just quickly run through some of these new features and how we develop them, and just point out some tech things, and then I'll do a quick demo. So we have one of the things we have is a custom legend. So we can query the KGS database for the extent, bring back the geologic units to display a nice geologic map legend. And again, you know, this goes back to that database work that we did when we digitized. Was we can display the units in stratigraphic order, so they're oldest to youngest displayed, and then it has their age and it has their nice name, and so that works really, really well. And then also we put a new little feature in here that you can double click the color of the map unit, and it'll actually highlight the centroid of those polygons. We use the layer functionality from the JavaScript API to create a group layer, so it looks like a GIS. So you cascade down into different types of features. So like oil and gas features are together, and water features are together, geologic map features. And then we also link from that layer list to the REST endpoint or a web page that gives metadata and information about each of those layers. Of course, it has transparency control, and then the legend for each layer is embedded in the layer list. Kind of a cool tool that we developed using our database was we we constantly had requests to create a bookmark, and frankly, the bookmark feature in the JavaScript API wasn't robust enough, so we developed a custom bookmark using our database. So if you select, you make your map configuration of the layers that you want, you click the bookmark, it actually saves that layer string of ID number of IDs into our database. And then when you recall that number, that ID number for the layout, queries the database and brings back those in layers and just displays those. So it's a nice way to recall the map in a URL. You can make custom bookmarks, make quick map layouts so that you don't have to reconfigure your map every time. And that was, we got asked to do that a lot. And it's because we have, 57 layers in our map service. So it's kind of necessary to do something like that. Custom location and ID tools. Again, we can query the database for the detailed geologic map description for a unit and bring it back and display it. I'll show that when we do the demo. And then IDing coordinates, we still use the Kentucky Geographic Toolbox that Brian Bunch developed many, many years ago to display the coordinates and the popular coordinate systems for Kentucky, Kentucky's single zone geographic coordinates, but also if you're an oil and gas user, Carter coordinates. That's really important and something that you don't get. You can't get Carter coordinates from ESRI tools. So to go to this map service, you would go to our website and just from the front page, click online maps, and then the link is sitting there. You can also access the map service from things like our oil and gas wells or water well search. We always link to the map service and then a layout that shows those features. So that's another way you can get to it. So, but let's go on and demo. And this is where I'll have to change my screen share. So bear with me for 2 seconds while I'm locked in this world. Okay, just do this. Sorry. So it's weird using 2 screens. Okay, bear with me. All right, so we're going to do a little demo. I'm going to try a demo. Can you see hopefully you can see. If you can't see the map service, just say something. So this is what it looks like when you bring up the map service. If you've used the old one, the big immediate thing is that you're looking at the detailed, that 1 to 24,000 geologic map data directly. So in the old version, you could not see this until you zoomed in, and it's just really nice to see that at the state level. You see you can just stare at this map for a while. And if you've been in our building, it's the same map that we display on our big, we have a big banner thing when we finish the mapping. Anyway, so we have an about. This kind of explains everything. And one thing about this map service, it's using newer web technology. And so if you don't have an up-to-date browser, use an Internet Explorer, you can use the previous version. We're going to keep that going indefinitely because the bytes are free. But we're not going to update that anymore, but it is still available. But anyway, the about kind of explains the features and all that kind of stuff. So put that about screen. Of course, you can zoom very quickly. And we're using cache layers finally in this, so it's a pretty quick zoom. Although when you zoom way in, we turn the cache layers off and turn on dynamic layers just because we didn't want to cache so far down, and that's something we can do in the JavaScript API, which is kind of nice. Click a unit, it highlights the unit. This is the Tanglewood limestone member, which is a big limestone around here that really important for the horse industry. But anyway, you can view the geologic description. So it makes a call to our database. It provides metadata to go back to where this description came from. And then you can read the description in here. So it's pretty detailed, has an economic description about how it was used, hydrology. That detail is not there for every single geologic unit. I just happened to sort of hit a gold mine here of this Tanglewood unit. But and then just straight up attribute data, again, links to metadata about it. And then you can dock that, of course, over here. So then the Brannon, so just another one. So these database, you know, storing that data in the database turned out to be super important. Let's see, so the map legends is here. And so it shows the detailed geologic units arranged from youngest down to oldest. So if you're familiar with the geologic timescale, Ordovician at the bottom, Quaternary with Devonian and between Mississippian. But if I double click on one of these, it will actually highlight the centroids of where that unit was mapped. So that might be useful for, say, a talk you're giving or something where you want to just highlight, you know, the upper part of the Lexington limestone without saying it's the green stuff. You can say it's the, I don't know, but there might be a lot of uses for that. I just thought it was kind of a fun thing to embed in there. So the layers, the layer list is, you know, where you do all the work. We have these quick map layouts. Again, using this bookmark tool, I'll show the bookmark tool in a minute, but you can quickly turn on and off layouts. So that's the karst potential map. And so you don't have to go down to the layer list to turn on and off all these things. You can just do that quickly. And actually that query layer that I made of the centroids is still there. But this is the karst potential map. It shows, I'll look at the map legend. It shows the karst potential for geologic units is determined by AGS geologists. Let's see, so, but you can, you know, turn on and off individual layers. And the nice thing is you can get way down in one of these, turn on the oil and gas wells, and it turns on that group. So you don't have to go back and remember to turn the group on and that sort of thing. But we have lots and lots of layers. I don't have time to go through all of them, but I encourage you to just go check it out. We even put state parks and trails from KY GeoNet on here, and of course Kentucky from Above layers. Really nice topographic map series, but also aerial photography where it's available. That detailed aerial photography, which is a little washed out because of the geologic units. I mentioned this bookmark tool. We have a bookmark tool, so you can create a bookmark and say you love this map configuration, you love this extent. You can save it without the extent, and that's the URL. It copies it for you, and then you have to make your own bookmark. You can't embed a bookmark anymore in people's browsers, but you can copy that URL. There's the ID number. Cool. But if you remember that ID number, you can just type it in here. So you can just quickly do that. So you don't, you know, if you write down these ID numbers, we have people that do that. And then you can save it with the extent. The URL looks like that, and it saves the coordinates and the whatever. I can't remember right this second. I think it's WGS 84. Okay, so that's the layer list. And then we have other tools, measurement tools. These are really just out of the box ESRI type JavaScript API tools, but widgets, but they work really nicely. You have a widget thing down here, gives you the distance. You can change to feet. Okay, that's 1,800 feet. You can do area in the same way. You can identify coordinates this way, which I think it takes a little getting used to, but it does work really well. You just have to get kind of used to how this tool works. But also, if you just click a unit, so I'm going to click. Oops, there's the identify. But we always provide the coordinates for wherever you've clicked on that map. So. And then I mentioned before that the one thing that ESRI can't provide is Carter coordinates because of a special coordinate system for Kentucky, and so we provide that. Much thanks to Brian Lynch for developing that tool because it works really great, and we've been using it for years. And then finally, zoom to location tool. So you can just enter an address, you know, whatever. You can zoom to an address, but we also, we've had this tool around for a really long time. You can enter a coordinate, you can zoom and plot. And then we have, you know, just some other features, you know, 7.5 minute scale quadrangles if you just want to zoom to, say, the Alcorn quad. Do that. So I just, I think I'm probably running low on time. I don't even know. But I just encourage you to check the service out. I'll attempt to go back to my PowerPoint here. That's the URL for it. You can actually, that's the URL. And I'll just leave that up. So if you want to write it down or whatever, but that's all I had. So thank you very much.
Does anybody have questions for Mr. Curl?
I don't know if there's some in the chat. Or...
Okay. Well, if we have no questions for Mr. Curl, we thank you all for attending this session. I do want to remind everyone to participate in the hallway if you want to. We will have the awards session coming up in a little while. That will be at 12:15. That's when our keynote and awards will be today. I just want to remind everyone of that. I do want to thank Mr. Curl for participating today. Thank you for your session, Mr. Curl.
Oh, thank you for having me, and I appreciate the.
All right.
Appreciate it. Thank you.
All right. Well, thank you. Thanks, everyone.
All right.
Thank you.